because the last one was awesome, and I think that this will be as well. So welcome.
All right, so let's get started. I'll start by briefly introducing myself. I'm Jonathan Davila, Principal Architect at Red Hat, part of the Ansible team. We were acquired recently, so still part of that group, and work largely on implementing Ansible with clients ranging from very small startups to Fortune 50 organizations and everything in between. Includes the public sector as well. So before I get started with the talk, who here has never heard of Ansible? Okay, excellent. So that means the majority of the room has heard of Ansible. For those of you that are familiar, how many of you would consider yourselves very amateur in the Ansible space? Okay, excellent. So what the talk's going to be about today is creating Ansible modules. Right? So before we get into that, I'll give a brief high level of what is Ansible, kind of an elevator pitch for those unfamiliar. Right? So Ansible is an automation tool for IT. And it's intentionally that vague because it can automate virtually anything in your IT stack, whether it's provisioning, application deployment, config management, you name it. Ansible is likely able to do some kind of automation around it. It's an agentless architecture, so you don't need to install anything on target nodes. It operates over SSH primarily, but can also operate against APIs and just make direct web requests. The UX of it, the user experience, is you write what you want to do in a YAML format, and Ansible executes it sequentially. So to kind of give you a look of what a playbook looks like, right? This is an example of one. So starting from the top, we have an area where we're targeting our web hosts. This is a reference to something in our inventory, your inventory being that which is your IT environment. We're defining some variables, or actually one variable called HTTPD packages, consisting of two elements, HTTPD and mod_WSGI. And then we enumerate the tasks we want to execute against a particular node. In this case, we're stopping firewall D, installing the libslinux Python bindings, and then iterating through the list we defined at the top to install the HTTPD package and the mod_WSGI package as well. Okay, so again, this is just a very basic overview. We're not going to be able to get too in depth. Just want to be considerate of everybody's time. And to give a little bit of a deeper look as to how Ansible works, right? So while it is YAML that you write as a user, it is not YAML that gets executed against the target machines. What happens is this YAML on the back end is translated into a Python script or a series of Python scripts that gets transported to the target you're intending to manage, gets executed, and then finally Ansible takes care of cleaning up that garbage on the target machine and gives you the result in standard out or standard error, depending how successful or not you were with trying to run your playbook. Okay, so an example of a module looking at the screen would be like the service module, right? It's a module that allows you to do manipulations against services, restart them, start them, enable them, etc. Yum is another module, right? So they're these individual components that allow you to do something. And at the moment, Ansible does have, I think, close to 500, if not just over 500 modules to do virtually anything you can think of at this point. So the place where modules reside generally is in two places. So when you install Ansible, the modules that come out of the box that are part of the open source project are installed in your Python path, right? Alternatively, generally when you're dealing with custom modules, you just place them in your current working directory underneath a library subdirectory, as you see on the bottom portion of the screen. Okay? And it is in this place where if you're unable to find a module in our upstream that can't help you out, you're more than able to, and to make your own, and Ansible can ingest it immediately. So that's what we're going to do in this talk. Is I'll walk through how you actually go about making a custom module in Python. Caveat with that, well, not even a caveat, just a side note, you can make modules in any language of your choosing. However, in Python it is exponentially easier because we provide a lot of helper libraries that take away a lot of overhead logic that you would have to do otherwise. Okay, so we're going to start with the basics of custom modules and the components that comprise them. Right, so what we're going to do today, and now we'll be doing this in a live demo, fingers crossed, hopefully it works. We'll be starting from our working directory, where I'll make a library subdirectory, and I want to make a Magic 8-Ball module. Now, this Magic 8-Ball module has very little utility in an actual IT environment, but for the purposes of demonstration, I figured it's something fun. All right, so what this module is going to do is it's going to take a single argument, or a single parameter called question, where we can supply any question we'd like, and when we execute Ansible, it will return with something Magic 8-Ballish. Right, so all signs point to yes. Try again, you know, and a response you would expect from your classical 8-ball toy. And we're going to add the additional functionality to where if the answer is negative, we're going to cause the playbook to fail. Right? We're only going to want it to succeed if the Magic 8-ball response is proper. And this should give us a pretty good overview as to how you make your own custom model. So starting with the internals, right? This is a very generic boilerplate as to how to make your own module. You start by defining a function called main, just conforming to typical Python standards, where we then instantiate an Ansible module object. In this case, we're defining a variable called module, and then we're defining it as an Ansible module object, and this is the place where we define the parameters. So if you look on the screen, I think about 6 lines down, you see param equals followed by a dictionary. The dictionary expression contains certain attributes we can assign to that parameter. In this case, we're saying this particular parameter is true, and it's a type string, right? And that's opposed to, say, Boolean or float, etc. Then in the subsequent section, outside of that object instantiation, we're defining a variable called param1, and this is just to normalize the variable that the user has supplied. So instead of having to reference module.params open brackets param1 every time, we're just going to have to reference param1 and we'll get whatever the user supplied as param1. Then, again, this is where we start talking about the helper methods that Ansible provides out of the box in its Python libraries. Whenever you have a successful state where you want to return to the user, you use the exit.json method that is a part of the module object, and you provide any arbitrary number of keyword equals value things that you want the user to be able to see. This is ultimately exposed to the user in JSON on the back end, which outside of the scope of this conversation, but it allows users to then leverage that JSON data any way they'd like later on in their Ansible usage. The next method is anytime there's a failure state. Right? So it's a typical pattern to capture anywhere where an exception could occur in your module code. You certainly don't want any tracebacks when people are using your modules. So you want to capture these, and if there's some kind of error, you want to return with fail_JSON. That is, again, a method available to the Ansible module class. And again, supplying any arbitrary number of keyword equals value pairs that you want to supply to the user, so then they can debug or take action accordingly. And then finally at the bottom, we're importing where all of the helper Python code exists. Right, so at the bottom we're doing from Ansible module utils basic import everything. And on a note on this is not a real import. It's a pretend import, in that it's not actually importing these modules on the target machine. What it's doing, and it's some magical stuff we do on our back end, is it appends the code of the basic library to your module code. So it's just one giant Python script, and it has all of these functions, and it just gets transported in a monolithic style to the target. That's kind of a workaround due to the limitation that we don't want Python library requirements on targets. We want a very minimal architecture set. And then finally we do an if name equals main argument, just to allow for mock testing later on. It's something that not every module does. It's just up to you, and if you intend to do unit testing or anything with nose with your module code. Okay. So now we're going to do a live attempt, and we'll walk through it on making this 8-ball module. So the API I'm going to be using It's at 8ball.delegator.com. It's some company made a RESTful API to, well, it's not even a RESTful API, just an API endpoint where you can supply a question to the end of the URL and it'll give you back a JSON response similar to what you see here. And I'll make this bigger so everyone can see. All right, so you get this JSON or dictionary value in return where you have a single object called magic and a few different attributes, question, answer, and type. And it is answer what we're going to return to the user, and it is type what we're going to reference in order to tell our Ansible module whether to succeed or whether to fail. Okay. And if we look at the URL bar, we notice the standard is, the URL is pretty simple, right? It's just the URL, magic JSON, followed by the question as is. So now I'm going to go into my terminal. And in my working directory, I have a handful of files. So I'll explain these. I have a README, just some basic documentation. Again, all of this information is open source and available for you guys to use. And I will add a link to all of this in the meetup comments as well. I have a big backup.json. We're not going to talk about this. Linode was down earlier, thus causing the magic 8-ball API to die. So this was my backup plan in the event that it stayed dead. Then we have a library directory. This is where our custom module is going to live. And then we have our playbook, shallwe.yaml. And shallwe.yaml contains the code we see in the top half of my screen. We're targeting localhost. We're using a local connection because we don't actually need to SSH into ourselves. And then I'm referencing magic 8-ball, supplying the parameter question, and the argument is shall this playbook continue. Okay, so very simple set. Any questions up until this point? So next I'm going to go into library. And in library I have my backup file. This is the answer, but we're going to do this from scratch to make it a little bit easier for everybody to grasp how to do your custom models. Okay, so starting from a blank slate, whatever language you're making your module in this case Python, you want to do your proper shebang. Right? So we'll start with that. And I'm simply grabbing the Python as part of my environment. I'm not doing the default OS X Python. I'm using homebrews, hence why I'm calling this Python and not the default one.
Not your screen is slightly off.
And I'll just move that up before I execute.
May you repeat why you said you're using that version of Python?
So the default OS X version of Python, I think it's at 2.7.10. Is it at 10?
Yes.
Between 6 and 10, depending on.
Oh, okay. I don't know. So for a while, the one that came with OS X was still stuck behind, and just to get frequent updates, it used homebrews. It's a matter of preference, really, at that point. This will work with either type of Python.
Or virtual env.
Yeah, or virtual.
Or virtual.
So we're going to start by defining our main function. We're not going to do anything here yet. In order to make sense of what we're about to code, I want to add our imports down at the bottom. So we're going to do from Ansible utils basic. Okay, and this basic library, it's open source. It's going to be part of the reference material I provide to everybody. It contains a ton of functions for you that you can use right off the bat. You can check the SE Linux context of a particular thing on the file system already, like that logic. There's already a function for that, so you don't have to do it for yourself. There's a lot of character type conversions, so if you need to do crazy things with Unicode or other, that funkiness happens with Python. There's a lot of helper methods inside of BASIC. And inside of modules, inside of the module utils directory, there's also several other libraries you can import. One that we're going to import now for usage for this case is URLs. And we at Ansible, since we do not like requiring dependencies on target, we unfortunately do not use requests. Right? So we use the whole URL lib2 and native Python libraries, and we've already taken care of a lot of the cruft that you associate anytime you're trying to manage URLs in native Python. So doing the same thing as with basic, just importing URLs. Okay. Now the first thing I'm going to do is instantiate my module object. Right, and that's a pretty straightforward thing. I create a variable called module, and it's equivalent to Ansible module. Right, an Ansible module is a class defined inside of that basic library. Again, this is the advantage of making modules in Python, even though you can make it in whatever you'd like. Inside of the class instantiation, or the object instantiation, we're just going to supply a single parameter, the argument spec, and that takes a dictionary of dictionaries. And from here is where we start defining our parameters, right? In this case, our custom module is only going to take one single parameter called question. So we say question, and the value of each parameter is a dictionary. And again, remember, this just contains that which constrains that parameter a user can supply. Right? So we're going to say required equals true, and the type should be a string. Okay. So should be relatively straightforward at this point. Any questions this far? If anything's not making sense, definitely let me know. Okay. So the next thing we'll do is normalize it so we can leverage question right away. So we'll say question equals module params. Okay. So just to make our code a little bit cleaner. Next piece is we're going to define the URL we're going to hit. Right, so we'll just define a variable called URL, and I'm going to grab that URL from the interwebs. And then I'm just going to do simple Python string replacement to append the question to the end of the URL. Okay. So now at this point we've defined the exact URL we want to hit. So the next thing we have to do is actually retrieve the data and do manipulations against it to drive our logic. So part of the URLs library that Ansible provides is OpenURL as one of the functions. Right? So pretty simple. Just OpenURL, and we supply URL. And we're going to do HTTP agent equals Ansible. Okay. Now the reason I'm doing this is this particular API, if you leave the default Python HTTP agent, it'll give you a 403 denied error, so you have to supply some non-default value. Now, we obviously just don't want to open this. We want to assign it a variable. So we'll call it R for, say, requests. Once we have this, we have the raw request, if you will, and you get a proper object. So we need to read this in, and at the same time convert it into something that JSON can parse. So we're going to use the Python native library, JSON, and just do a JSON loads to make it parsable. So we'll do data equals JSON loads, and then R. Okay. So for those new to the Python world, JSON loads is a pretty common method. It allows you to take a string, it actually stands for load string, that is JSON, and then properly encodes it into valid JSON. And JSON in Python can be treated largely like just the Python dictionary, so it makes it very easy to work with. Okay, so at this point we have data, and data should represent this structure. So now that we have this data structure, we can start accessing attributes. Okay. So we notice the object is magic, and we want to get the answer first. So now we'll say answer equals data magic. Okay. So just a direct mapping from what we're expecting from the API. And we're going to do the same thing with type. Okay, so right now we're not going to add in any logic to cause the playbook to fail. We're just going to allow it to succeed every time, whether the message is affirmative or negative. And we'll do that with simply module exit JSON, and we'll say changed equals false because no changes actually occurred on the machine, and then we'll supply answer equals answer to provide that output, followed by type equals ANS underscore type. So at this point we're done. We've made a module. The logic's going to be improved in the next step, but we'll go ahead and run this just to give you an idea of what that looks like. So now if I go back to the root directory I'm working up, close this. Alright, we're going to run shallwe.yaml through Ansible Playbook, targeting localhost, and we'll see what the output gives us. Alright, to give a brief overview as to Ansible syntax, right, we're supplying the Ansible Playbook command. We're specifying the playbook we want to hit, which is shallwe.yaml. The -i flag specifies our inventory. In this case, we're just targeting localhost, so we're just doing the localhost comma. So we don't have to reference an actual file, it's just an inline inventory definition. And then a -v to add a little bit of verboseness to our output. Let's see what happens. Oh, I forgot I used interpreter. Yeah, you're right. Syntax editor. That's what happens when you live code, right?
Better man than me.
Peter's not on fire yet.
Okay.
It says green!
Hey, we're successful. Alright, so we see the output now, right? We got back as a proper JSON response. The answer, don't count on it, change was false, and the type is contrary. Right? So if we keep running this, we should get slightly different, oops, not SSH. So I keep doing this, right? Reply hazy, try again. We just keep doing this over and over again to get different magic API responses, right? So now the next thing we're going to do is we're going to add in the logic to where if the type is contrary, we're just going to cause the playbook to fail and be like, sorry, contrary.
Is this how you make all your life decisions?
Yes. Yes.
Most definitely.
All right, so at this point, just a very basic conditional, right, where we say if, let me move this up a little bit for everybody. If the answer is contrary, we'll do a module, fail JSON this time. we'll supply a message argument, say, sorry. And then we'll also supply the other values. So we'll say answer again equals answer, and type equals type equals int type.
Do you want to check against the int type there?
On the previous.
Yeah. Yeah. Thanks, guys. Okay, so now we have our logic, right? So fill JSON will cause an error. Ansible playbook as a result will exit with a non-zero return code, and if the answer type's negative, otherwise it'll go through and you can continue on with your playbook's execution. So now let's go ahead and run this. All right, and we notice this is affirmative, so it went through as expected, and we'll just keep doing this until we get an error. Should take. There we go. So now we got a failure, right? Because we got a answer very doubtful, which is a contrary answer, and now we have our custom module all built out. So that is it. I mean, that's pretty straightforward for creating your own module. There's really not much to it. For those who want to make something in not Python, the way Ansible passes in arguments is as key equal space separated key equals value arguments to standard in, right? So if I were to not be using our helper libraries, I would get question equals and then the value of the question, and then it would be up to me for my programming logic to do the parsing and any other necessary logic. So that's it. Are there any questions?
Is Solaris a first-class citizen in the Ansible world?
It is.
Cool. And is it 2.7 only?
For the Python version?
Yeah.
No, so the only requirement that's the target needs to have is Python 2.4. Yes.
So one, I want to say thanks for Ansible. We've been using it for like a year, and we haven't started hating it yet, which is amazing. There's almost no tools that I use for that long that I don't hate it some. In a custom module, let's say I did want to use a third-party library. Let's say just I love requests more than anything.
Yep.
We've been doing this in like goofy ways, like we install an egg with a virtual environment and then execute it. Like just shout it, execute it. But like, is there a way to send a third-party library along with your module, or?
So not in a way. I mean, there is. You just have to modify. You would have to like rebuild your. You have to build your own Ansible basically at this point. But you
Sounds
would.
great.
Right. There's no native way to do it like the way you can do custom modules or like some of our other custom extensions. What I would suggest, like for requests in particular, is look at URLs because it's requests-like in its behavior. So it takes away a lot of the heavy lifting. But for now, I think you would have to make sure that request is installed on whatever targets. So
If I, okay, can I hard code the shebang and then just like have a virtual environment onto the target?
yes, yeah, you could.
Okay. Okay. Thank you.
Yes.
How common are custom modules?
So yes. So custom module use cases, I've noticed two main patterns with very rare outliers. One is large organizations that have internal applications that don't exist anywhere else. So of course, no one's going to make an Ansible module for it outside of that organization. That's one. The other piece is usually like very obscure things that nobody uses, but I mean are still out there. There's just not a big user base. So I'll give you an example. There's a public cloud provider called Dimension Data. One of the clients I was at recently uses them, but nobody's ever heard of them. But they have an API, so they wanted some modules made around that, and so as part of the engagement, we did that for them. So those are the two common bits. Outside of that, it's not very common. Usually what we provide out of the box is more than sufficient. The other thing to know is if you're ever working with Ansible and you encounter a bug in one of our modules, and that bug has been fixed in our upstream but hasn't been released in one of our official releases, you can just simply drop that into your library directory directly from source, so you get the patched version, and then then you can remove it once it's been part of a release.
What is the preferred way of distributing modules with organization? Like, because I've used Ansible Galaxy before trying to deal with internally, but I think most of the documentation of that involves installing things globally to the system. It might have changed since then.
Yeah, so I know what you're talking about. So I'm just going to give everybody like a quick snippet on the Galaxy. So Ansible Galaxy is akin, for those like familiar with the Docker world, to like a Docker hub, where people can contribute Ansible code, share it with whoever has access to the internet, and then people can pull them down, do whatever they want with them, and leverage them. But to that same effect, that same mechanism can be used in a private repository world, where if organizationally you want to share what are called Ansible roles across different groups, you can do so using Ansible Galaxy without actually needing to use our public web app. So this question is coming around to what's the best way to distribute custom modules across an organization. And it's going to depend on your setup. So I've seen a couple different ways. One, I know the one you're talking about, using it internally and then doing a global setting. That has everything to do with, by default, when you're doing Ansible Galaxy install and then the requirements.yaml, which is what I'm assuming you're talking about, it'll install to the path defined in your Ansible CFG. If you don't have an Ansible CFG and you're running off of just defaults, then yes, it'll install an etc Ansible roles or whatever. So one option is to have an explicit Ansible config. The other option is at Ansible Galaxy install time, you can do a -p flag and specify the path where you want that role installed. That's the other way. Other mechanisms we've seen is, again, like have them installed on like a shared file server, and then people could just reference the same directory across different systems. It just depends on the use case. Any other questions? Okay. Thanks, guys.
Okay. Let me pause.